Hello geometry students! In this video we are going to learn about the Pythagorean Theorem. We will learn about the converse of the Pythagorean Theorem in a separate video. So the Pythagorean Theorem is something that you've probably already done at some point before. The Pythagorean Theorem, so it says a squared plus b squared equals c squared. And we use this when we have right triangles. We can only use this when we have a right triangle. And important to note that c is always the hypotenuse, which is the longest side of our right triangle. It is the side that is across from the right angle. So let's verify this for just a moment. Let's take a look at a figure right here. Let's say that the smaller leg over here is A, and the larger leg is B, and the hypotenuse is C. Well then, when we talk about the area of this square over here, this represents A squared. The area of this square down here represents B squared. And the area of this square up here represents c squared. And we can manipulate these pieces so that a squared and b squared fit perfectly on the c squared piece. If we move these pieces around, we can take part of our b squared here, that, and this, and this, and this. There's our b squared. And then if we put our a squared in there also, then we can see right here that the a squared piece and all the parts of the b squared pieces fit perfectly together to fit inside the c squared piece. Okay, so let's solve some problems using the Pythagorean Theorem. We're going to do these with algebra, and we're also going to use Desmos to do these. So first, we're going to find the length of the missing side. We want to make sure to always label our hypotenuse side. So the first thing I'm going to do is just label each of these. I'm going to mark over here, this is my hypotenuse. And in each of these problems, over here we have smaller triangles, two smaller triangles that are right triangles, so I'm just going to focus on this one right here. So when we set up our problems right here, this one, these are our A and our B. It doesn't matter which one we call A and which one we call B. We're going to square them and add them together, so that order doesn't matter. We are going to solve 9 squared plus 12 squared equals x squared. And when we do this using algebra, 9 squared is 81, 12 squared is 144, so that equals x squared. When we add 81 and 144, we get 225 equals x squared. Now, our side isn't 225, 9, 12, and 225 wouldn't make sense, but this is x squared, so if we want to get it to just x, now we take the square root of both sides, and the square root of 225, you can use your calculator to get this, is 15. The square root of x squared is x. So we have that our x value is 15. Now if we wanted to use Desmos for this, we could just type in 9 squared plus 12 squared equals x squared, which I'm going to come over here to Desmos and do that. So we can just type in right here, 9 squared plus 12 squared equals x squared, and then Desmos will graph it for us. Now it doesn't graph us anything on our main screen right here. This goes between -10 and +10, so this must mean that it's bigger. So if we move over a little bit, then we'll see that our x value right there is at 15, and that makes sense because it's the biggest side in our triangle, so it should be bigger than 9 and 12, so 15 makes sense. Okay, now let's try problem number 2. This time the hypotenuse is our, we know that side, and that's 34, so we'll set up our equation as x squared plus 16 squared equals 34 squared. Now first using algebra, x squared, when we square 16, you can use your calculator if you need to, we get 256. And when we square 34, again, use your calculator if you need to, we get 1,156. Now when we subtract this 256 from both sides, we will get that x squared equals 900. And we'll take the square root of both sides, and we get that x equals 30. And this makes sense because we have 16 and 30, and both of those sides are less than the length of the hypotenuse, which is 34. If we wanted to plug this into Desmos, well, let's come over here to Desmos, and we would plug in we would do x squared plus 16 squared equals 34 squared. And again, we don't see anything right here. It's not between negative 10 and positive 10. So we want to drag our screen. Let's look for the answer, and we're only interested in the positive values here. And we find over here that we get 30 for our value of x. Okay, now let's do our third problem over here. And for this one, we have a triangle that's split into smaller triangles. We were just learning about congruent triangles last unit, and we have two right triangles here, and we have that the hypotenuses are congruent and this leg is congruent. So hypotenuse, leg congruence. Our two triangles are congruent to each other. That means that this 18 right here has to be split into 9 and 9. And then when we solve, we have x squared plus 9 squared equals 41 squared. Using algebra first, x squared plus 81 equals 41 squared. Use your calculator. That's 1,681. When we subtract the 81, we get x squared equals 1,600. And we'll take the square root of both. The square root of x squared is x. The square root of 1,600 is 40. Let's go over and see how we would plug this into Desmos. On Desmos, we would plug in x squared plus 9 squared equals 41 squared. And if you want, you could just zoom out on here until we see, oh, and there we go. We get 40 as our solution, which again makes sense because even though it's kind of a big number, it's still less than our hypotenuse over here of 41. Now, you should take a few minutes to practice doing these problems. Pause the video, practice them, and then come back and check your work. I will pause for a moment, and when I turn it back on, you will see all the answers there. Okay, I hope you had a moment to work out these problems. Here's number 1, 2, and 3. So I have worked out each of these problems using algebra, and now I'm also going to show how to solve each of them using Desmos. For each of these, it's important to note that no matter what our variable is in our problem, when we use Desmos, then we would always want to use x as the variable. We don't want to type in c or a or b ever for Desmos. So let's head over to Desmos and solve this first one right here. And for this first one, we would have 7 squared plus 9 squared equals, in our problem we had c, but here we would type x squared. And when we do this, if we drag over a little bit, we see that it's between 11 and 12, and if we click on it, then we get that it's 11.4. In our algebra problem, we got the square root of 130. And if you use your calculator on the square root of 130, you'll find that the answer is 11.4. For number 2, this one came out to be a nice integer value, making sure to put the 39 over here as our c, and we get that a is 15. If we wanted to use Desmos for this, then we would type in, instead of a, we would type x squared plus 36 squared equals 39 squared. And we can see that our answer is 15. For our third problem, we have 40 squared plus b squared equals 41 squared. And when we solve this using algebra, we get b squared is 81. The square root of 81 gives us b is 9. If we were to solve using algebra, we could type 40 squared plus, we wouldn't want to use b squared, always x squared equals 41 squared. And we see right here that the answer is 9. We always want to check to make sure that our answers make sense. The hypotenuse needs to be the biggest number. In number 1, the 11.4 is bigger than 7 and 9, so that's good. And number 2, the 39 is bigger than the 36 and the missing side, which is 15, so that's good. And in number 3, the 41 is bigger than 40 and 9, so that's good. 3 more problems right here. Now these have a little bit trickier. I'm going to take a moment and work out number 4 with you right away. On number 4, we have the square root of 6 squared plus the square root of 19 squared equals t squared. And I forgot I said I wanted to highlight my hypotenuse each time. And when we do this, when we square a when we square the square root, the square and the square root are inverses of each other. So the square of square root of 6, when we square the square root, then we just get 6. And the same with the 19. When we square the square root of 19, we just get 19. So 6 plus 19 equals t squared. So 25 is t squared. And then we take the square root of each, and we get that t is 5. If we were to go put this into Desmos, then we would put in the square root of 6, make sure to arrow over, squared, plus the square root of 19, arrow over, squared, equals, instead of t, we would want to put in x squared. Then we see that our answer right here is 5. When we come back to problem number 5 here, excuse me, then we get y squared plus 12 squared equals 15 squared. 12 squared is 144, and 15 squared is 225. And when we subtract that 144, we get that y squared equals 81. So square root of each, we get that y equals 9. If we were to go over to Desmos, instead of putting in y, we would want to always put in x. X squared plus 12 squared equals 15 squared. And then we get that our answer is 9. And for our last problem here, z is our hypotenuse. We would use 10 squared plus 10 squared equals z squared. 10 squared is 100. 10 squared is 100. So when we add those up, we get 200 equals z squared. And we'll take the square root of each. Then we get z equals the square root of 200. We could use our calculator for that. The square root of 200 comes out to be about 14.1. If we were to go over to Desmos to do that, then we would say 10 squared plus 10 squared equals x squared. Then we get our answer over here as about 14.1. And again, always check to make sure that your answer looks reasonable. The hypotenuse should be the biggest number. So on number 4, T5, it's bigger than these other numbers. If you wanted to confirm that, you could use your calculator to see what is the decimal value for square root of 6 and square root of 19. And number 5, 15 is bigger than the 12 and the 9. And on this one over here, the 14.1 is bigger than the 10 and